Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and today we are diving into an important concept in probability, that is bivariate discrete cumulative distribution function. This concept is essential for understanding how two discrete variables interact in probability theory and statistics. So let's get started. So here if we talk about two-dimensional joint distribution function, so it is defined as fxy, that is x is less than x and y is less than y. And to show it is it's like taking an example that will clear all your concept. So that is a joint probability table of x and y. So here x values are from 1 to 3 and y values are 1 and 2. So these are the probabilities. Now see that here, let us see the numerical example. So if you want to find out this cumulative distribution function, so what will we do? F22, that means P, the value of x would be less than 2 and value of y would be less than 2, and we will start from here. So that would be equal to Px equal to 2y2 1 y2 x2, then y1 x1 and y1, all possible, you can say that pairs we will take, because here we haven't taken 3 2 or 2 3 2, because here the value we can take the value of x till 2 and value of y till 2. So we will add all probabilities, you can say that here. This one 0.3, because x is equal to 2, y is equal to 2. So I have taken this one 1 and 2, x is equal to 1 and y2, that is if x is equal to 1 and y is equal to 2. So that would be equal to this one, and fourth one, if I take this one x is equal to 1 and y is equal to 1, so that would be 0.1, and this one for x is equal to 2, y is equal to 1, this one actually 0.1, you can see from the table. So that will be equal to 0.7. Now for F32, so let us see, that means the value of x is less than or equal to 3 and the value of y is less than or equal to 2, and let us express it. So that would be equal to, we can add this one plus x is equal to 3 and y is equal to 2, x is equal to 3 and y is equal to 2, x is equal to 3, y is equal to 1. That means we can also add from here, and the remaining x is equal to 3 and y is equal to 2. That means that would be equal to 0.7, that is here, and these two expressions. The important thing is that you have to pick up the data probability from this joint probability table. That is one, because we are adding all values. Fx3, that is marginal CDF. So F3, so x is less than 3 for 1, 2 and 3. The same way y1, so we have to take here py is equal to 1, and we will get 0.1 plus 0.1 plus 0.2. Here it also means that means y is equal to n and x will vary. So that would be for f1. So let us see joint and marginal distribution functions of discrete random variables. So here the distribution function of two-dimensional random variable for all real x and y defined as this one. And thereafter let us see another example. Joint probability table is given here. X can take 0 and 1, y can have 0 and 1. That table would be of 2 cross 2, and that means 4. And pf00, that is x is equal to 0, y is equal to 0. That is this one. The same way f01, so that is x00, that is 2 upon 9, and x0 y1, so that should be here. Let us see that. So 2 upon 9 plus 1 upon 9, this is 3 upon 9. The same way f10, so that means x is equal to 0 and 1, y is always 0, because for all values y would be 0. For all values of x, y would be 0. So let us see the values from the table. Again, that is 3 upon 9. F11, so you can see that there are F00, 01, 10, 11, means all four values you are taking. So obviously that would be 1. So hope you understood. For more resources you can visit website, YouTube channel, Facebook page, and you can also connect to LinkedIn page. And I hope you will support my channel, you will subscribe, you will follow Facebook page, you will follow LinkedIn page, and you will also visit postnetwork.co website. So thanks for watching the video.